Let's dive into a more compressed JavaScript to figure out, or try to figure out more about this cloud thing. There is another call to the backend to get an external overview, and that returns something called a site name and a list of power modules. Within the list of power modules is a list of faults, as well as something called geolocation. And within geolocation, there is a latitude and longitude. And from looking at the installation manual, where the human machine interfaces, there is a fin up here, which is like a cellular LTE module where the components inside the Carno can talk to something somewhere. So one idea is that this cell thing knows where the Carno module is at, and it would be positioned kind of above where these kind of it's just a bunch of wires in here, but it would be like located somewhere up in the upper right hand corner of this picture. And this is from the Monroe live video. And very briefly, Josh opens up the human machine interface part. And you can take a look at the inside, but you can't see all the way inside. But that's the touchscreen monitor, and there's two cables, two wires, green and a black one, and they go up and then they disappear. And then there's a darker green and a black wire, and they go down. So if I were to take an educated guess, one of the computer that talks to this, uh, that basically talks back home, would be located somewhere between where the top two wires are and where the bottom two wires are. And if you take a look closer at this picture, there is a black box with a piece of tape on it. And keep in mind that this thing is also going to have to optionally connect to this cellular module that sits on the top of it. So it could be that, but I don't know. And if you scroll down more, there's a small kind of gray box down here. It could be that. And then in the middle, it looks like there's two boxes, and on the closest box, there's a bunch of Ethernet or network cables plugged into it. There's four blue ones, two black ones, a space, and then another black one. And it looks like there's a similar box, just looking from the labeling, right behind it, but I can't tell what's plugged into that. But from this aerial shot of the Carno, this is the one at the Ohio Research and Development Facility. And if you look closer at it, it appears that there's no cellular module where it's supposed to be. So I have a feeling that thing is not connected to the internet, which is a good thing, because you don't want like a prototype for the Navy connected to the internet. So I don't know, China and Russia could try to knock on its door. That would not be good. And here is a closer pixelated view. So, and if there were to be like a cellular module on it, it would be in this location. But I don't see any LTE module sitting on top of it. It could be in another location, but my guess is it's not there. Looking at a more compressed JavaScript, there is a table layout that has a Carno core ID, device ID, a company, a Carno power module, and then there's different states. There's uninstalled, quarantine, registered, and is simulated, as well as this last data ingestion time and last data real-time data time. So we can add a few more fields to kind of this data layout in the devices table. So there could be a registered, quarantined, uninstalled, and is simulated columns in this database table. And I have a feeling that the cores and the devices tables may be the same table, but I can't confirm for sure. But there is another table column in here that's called KASS auth ID. So you got to look around on the internet to figure out what that is. And there's something called a key scaler as a service, starting at 35,000 for 1 year, and it provides identity security solutions for IoT, that's the Internet of Things deployments. In today's interconnected world, the reliance on connected devices has become essential for business seeking efficiency, performance improvements, and a competitive advantage. However, trust in these devices and the data they generate is paramount, and this KASS platform offers a cloud-first solution that ensures IoT device trust through one-click deployment of PKI, and that's a term for private public key infrastructure services, and automated device identity lifecycle management for IoT at scale. And it goes on to further say that this is hosted in the Microsoft Azure platform. So I have a feeling I can expand this IoT hub box to have almost like a key scaler add-on next to it, and somehow the back end talks with these two. It may talk to the IoT hub, it may talk to the key scaler, or talks to this key scaler through the IoT hub, and somehow the key scaler provisions keys for these devices. So it's kind of like a key maker or key manager. And there's another, the last paragraph says the components of KASS are hosted on the Microsoft Azure managed application platform, which dynamically scales components as global loads vary. Then on the second paragraph, the last sentence says the platform utilizes a secure multi-tenant data model, providing each tenant with dedicated silos of environments, secure repositories, and cryptographically isolated databases to ensure the highest level of security. So if you have 3 different companies, they're going to have 3 different databases that this key scaler talks with. And that would turn the diagram into here. So if you have company A, we don't know who company A is, but it would have its own database with its own keys. Company B would have its own database with its own keys. And company C would have its own database with its own keys that would pair with all their devices. Now, I can't say that the backend database, if it's divided by company, I don't think it is, based on this next API call, because you can issue to the backend a patch, which is an update to this CORS endpoint on their backend with a device ID and the company ID that you want to change to, and the front end responds with successfully updated device company. So I have a feeling all the information is in one database on the back end that this thing talks to. We go to the right diagram. But if you're going to have like commercial applications and military applications, my guess is that that military application would be on its completely isolated platform, because they don't want to get some vehicle charging startup accidentally being able to see like autonomous vessels. You want to keep those segregated. So I have a feeling that the military is on its own separate secure platform, and then all the commercial stuff is on a separate platform. More endpoints is external overview RTE. My guess is that RTE is real-time data, and you pass in a parameter called a PM underscore ID, and PM stands for power module, and it returns a list of something that contains real-time KCU. And in the last video, people were trying to guess what KCU was. Some people are saying it's a Carno core unit or a Carno control unit. And I had to actually go out there and look around some more. And I had to do like, if I do like a search term for KCU, it's like, it didn't know, but I had to do like IoT, KCU, KMS, MCU, LTE, and then it finally gave me something called COFER bits, the smartest vehicle control unit. And this is a guess. I mean, I'm guessing it could mean this. I can't confirm. But you have to keep in mind is before the Carno generator, they were doing the Hypertruck ERX, and they were pulling data from trucks, and they could have had like 1,000. They could have bought 1,000 Kofor-bit KCUs, and they said, "Well, we're not doing trucks anymore. We're going to switch to the Carno. What are we going to do with all these KCUs?" And one guess is, well, we could stick these KCUs in these Carno enclosures and monitor things with them. But I could be wrong. It could be a Carno core or Carno controller unit. I don't know. There is also another call to external overview slash RTD, and instead of giving it a power module ID, you give it a power module serial number, and it returns a list of something that contains the power module ID and this real-time KCU. The only real things I could see the front end doing with this real-time KCU is there's something called CANOUT underscore Carno unit STSF DBK. And there's a piece of code that in the front end that says that the fault status is not good, or if this variable is either true or if it's greater than 0, then it's going to return something called a faulted table class. So this has to do something with some sort of Carno fault. The next field is DC voltage, and there is a Carno high voltage bus actual voltage. Another field is electrical output and power Carno power out underscore MP. I don't really know what that is, but that's the only thing I could really see the front end doing something with this real-time KCU. There's other references, but I can't tell what it's trying to do with the data that's being returned. There's telemetry. Get from the back end telemetry slash raw, then you give it a start date and end date and a Carno ID, and it appears to it looks for a file reference that ends in .mf4, and that is a ASAM MDF file. And these files focus on persistent storage of recorded or calculated measurement data for post-measurement processing, offline evaluation, and long-term storage. A primary application in the automotive industry is the recording of signal data during measurement, calibration, and testing of ECU systems. Typically, the signal values are acquired from sensors or transferred over a vehicle bus system. This includes recording of ECU internal variables or of the complete bus traffic itself in form of bus events. Bus events are not talking about bus vehicles. It's a computer hardware term. Since the emergence of advanced driver assistance systems, the recording of synchronized video data and radar information turned up as a new use case, which is also supported by this file format. After the measurement, MDF files can be used to display the recorded signals in a graphical or tabular representations. Offline evaluation tools offer manual or automated processing, classification, and evaluation of measurement data. So this returns measurement data of particular things within the Carno core units. I don't know what they are, but they do have endpoints that but I can't tell what it does with this data. There is an endpoint, makes a call to get telemetry signals of this KCU, and it returns something that has a name. That's the only thing I can tell. And then there is another endpoint, telemetry slash data underscore dictionary slash KCU, and I don't know what it does with it, but it does make a call out to it. Now, let's get to control. There is a back-end command that the front end makes that does a post to control slash power. You give it a Carno ID and a power underscore kilowatt. So I have a feeling that this controls how hard the Carno module runs at. And if there is also another one, a variation of it, if something called reoccurring is true, it does a post to control power schedule, and it gives it a Carno ID, a power, and kilowatts, an optional voltage. There is another parameter called recurring. -1 stands for never, and then 0 through 6 denote either Sunday, Monday, Tuesday, Wednesday through Friday, and Saturday. And then you give it a start time in a 24-hour format in terms of hours and minutes. And then there is another command to delete a schedule event, which is delete control power, and then you give it a command ID, and the front end responds with successfully deleted event. So that's it for this video. Delving more into this cloud and seeing what it can do. Thanks for watching.